In this lesson, we are writing equations of polynomial functions, where we're going to find all the zeros and then write the equation using those zeros. So in the first review example, it asks us how many roots there are. Remember, roots are the same as solutions. The other words we can use are zeros and x-intercepts. So remember that our degree, the highest exponent of our polynomial, tells us how many solutions or roots there are. So in the first example there are 3, and in the second example there are 4. We also remember that imaginary or complex conjugates always have to come in pairs. So if 2 plus 3i is a solution, then 2 minus 3i is also a solution. That's the complex conjugate. If 5i is a solution, then we know that negative 5i is a solution. So if we take a look at a polynomial function, let's use a quadratic for instance. If I have x squared plus 5x plus 6 equals 0, and I want to find the solutions, what I can do is I can make my x. I know that multiply and add, so what two numbers multiply to be 6 but add up to be 5 would be 2 and 3. So my factors would be x plus 2 and x plus 3 equal to 0. So there's my equation, and now it's in factored form. So to find the solutions, I set these equal to 0 and I solve. So can we work backwards? And if I am to give you the solutions, such as x equals negative 2 or x equals negative 3, can we work backwards to put these into factored form, and then can we write the equation? So here's what we'll do. We know that the solutions are 7, 3, and negative 4. So reversing the operation, instead of having 7, I would subtract 7 from both sides. So I'd have x minus 7 equals 0. Subtract 3 from both sides, so x minus 3 would equal 0. And add 4 to both sides, so x plus 4 would be equal to 0. And then to write the equation, I would just put those together. These are my factors. So on the next one, I would do the same thing. So if x equals 2, I would subtract 2 from both sides, and x minus 2 would be one of my factors. So if I have x equals 3i, I would subtract 3i from both sides, and x minus 3i would be one of my factors. And if I have x equal to negative 3i, I would add 3i to both sides, and that would be my other factors. So I'm hoping you will be at the point where we soon can take a shortcut and not have to write all of this out, that you know that you needed to do the opposite operation to make the factors. So if I go down to the last example in this box, if x equals 5, then I know that x minus 5 is one of my factors. If x equals negative 3, then I know x plus 3 is one of my factors. X minus 2i would be a factor, and x plus 2i would be a factor. Now it's a little bit different when we have something like 3 minus I and 3 plus I. So first of all, we would know that x minus 8 would be doing the opposite. So what do we do for this one? So we have x equals 3 minus I. I need to bring both of those terms to the other side. So I'm going to subtract 3, and I have to add I. So one of my factors will be x minus 3 plus I. Same thing here. I have x equals 3 plus I, so I subtract 3 and I subtract I. So I have x minus 3 minus I. Those are a little trickier, but it just does become the opposite of both of these values. So it's the opposite of each of these, the opposite of each of these to make our factor. So this says write a polynomial function of least degree, which means we're only going to use the factors given to us, with a leading coefficient of 1 and the following zeros. And that's exactly what we were doing. So instead of positive 1, we do the opposite. Instead of negative 4, we do the opposite. And instead of positive 5, we do the opposite. The leading coefficient is 1. We're only using those roots. That's least degree. And we're going to set it equal to 0. Or we can also say y equals or f of x equals. Okay, next example. Leading coefficient of 1, and 1 is one of my roots, so that's going to be x minus 1 as one of my factors. Then remember we have to do the opposite of both of these, so it would be x plus 2 minus I, and x plus 2 plus I is equal to 0, or it could be equal to y or equal to f of x. Now we have to be very careful when we're looking at these, because remember that imaginary numbers always will come in pairs. So that means there's also a 3i as a solution, which means that we have 4 solutions on this one. So x minus 2 will be one of my factors, x minus 3 will be one of my factors, x plus 3i will be one of my factors, and x minus 3i will be one of my factors. Because there are 4 solutions, we have 4 factors. All right, number 6. Again, they only gave me 4i, so we know negative 4i is also a solution. And they gave me negative 3i, so we know that positive 3i is also a solution. So my factors will be x minus 4i, x plus 4i, x plus 3i, and x minus 3i equal to 0 or equal to f of x or equal to y. And that is writing the polynomial